Hi guys, I'm Professor Robinson. I'll be doing your anatomy refresher series for this session, and today we'll talk about the spine. So just as a refresher, the skeleton overall has a number of different functions, and it's important to remember that it is a living thing. That sounds extremely obvious, but it's easy to sort of think of them like as you might find them in an archaeological dig, right? Where they're just sort of rocks or they're just sort of scaffolding, but they're a really, really active part of our bodies physiologically. So the skeleton supports ourselves, obviously. It's an anchoring point for our muscles. It helps keep us upright against gravity. Bones themselves have this sort of dual nature to them where they are very, very hard. They have this impregnation of hydroxyapatite, this calcium compound that gives it hardness, and also a collagen structure that it's all built on. So you end up with this hardness from calcium and this sort of basic flexibility and shock absorption abilities that's inherent to having a collagen frame. Together, these two help keep you upright. It helps keep you moving around against the forces of gravity, and in such a way that they can resist impact and trauma without being overly brittle. They also serve as protection. Your skull, rib cage, and pelvis are your main areas. Your skull obviously is going to protect its contents, the brain, and even your orbit, your bony orbit, helps protect the eyeball inside of it while only exposing enough of that eyeball to the outside world that you need to see. Your rib cage is going to protect all of your thoracic organs and a little bit of your abdominal organs. Your spleen is sort of tucked up behind your ribs. This is this person's left, so spleen would be sort of there-ish, and part of the liver would actually be tucked up behind the ribs as well. Your kidneys, let me get the eraser out. It's okay. Kidneys are going to be right about there and also somewhat protected by your lungs, or by your ribs. Your lungs are inside of your rib cage and your heart is in there too. Anchorage, again, a place where your muscles are going to attach. You also are going to attach your skin directly to these muscles sometimes as well. So to have, if your muscles are attaching into something that's already pretty movable, you need to make sure that its backboard, so to speak, is already pretty firm. Mineral and growth factor storage. So the mineral is primarily calcium in the form of hydroxyapatite. And growth factor storage, this is, you think of bones as being influenced by growth factors, but they also house them too. So you end up with like insulin-like growth factor, IGFs. You have transforming growth factors, transforming growth factor beta. You have fibroblast growth factors, platelet-derived growth factors, and bone morphogenic proteins. All are going to be housed within the bones themselves as well. Blood cell formation, this is really important. This is going to take place in your red marrow, which is in the ends of bones, irregular bones, in your flat bones, your short bones, like in your wrist. Your flat bones are where you're really going to be making the most sort of as an adult. So that would be once again in your ribs and in your pelvis. If you're going to be doing a bone marrow transplant, they're going to want that red marrow taken out for all of the stuff that it's all the blood forming cells in there. So when they're going to get that from somebody for transplant purposes, they're going to generally go into the pelvis. And finally, for fat storage, this is mostly what we're going to think of when we go to yellow marrow, ROW, and that's in long bones, in the diaphysis of the long bones. So all in here, you're going to find your marrow. This is what, if you eat marrow at a restaurant, then this is the kind of marrow you're eating, and it's fatty, so that's why it's delicious. In total, you have as an adult 206 bones. As an infant, though, when you're first born, you have quite a number many. You have more like 300 bones in infants and newborns. As you get older, that number is going to get lower and lower and lower towards the number of 206. Your bones are largely cartilage to begin with, and they ossify over time. So when you're born, they are partly ossified, and as at the ends and past those growth plates, you're going to have further ossification, and this is going to end up creating a lot of smaller bones in the meantime. This X-ray series you can see of somebody through their lifespan, you can see how you have this sort of end point here, this little nub there that grows. That's part of the endochondral ossification. Endo meaning inside, chondra meaning inside of cartilage, ossification meaning like turning something into bone. And it grows in a little bit more, gets a little bigger, so forth and so on. So for a while, these are going to be considered and thought of as being like separate bones because they're not actually attached to the quote unquote parent bone. But as they fuse, they're going to be considered part of the larger bone. And by the time you get to be an adult, you can see that they are fully merged and really, truly one structure. Your skeleton overall is divided into two major parts. You have an axial skeleton and an appendicular skeleton. The axial skeleton makes up the long axis of your body. You can see over here on the right. This is where all of your organs are. You do not have any organs in your appendicular skeleton, and it is everything between the head and the spinal column. So as we talk about the spine today, you can see that not only is it part of the axial skeleton, which is very much a midline series of bones, but is the most midline and ultimately the major support point for all of the other axial bones. Your appendicular skeleton is all of your limbs and those girdles. So while your pelvis, for example, may seem like a midline structure, it is actually appendicular because it's sort of like your leg girdle. Your scapula seems like it ought to be sort of a midline-ish structure, but it is in fact also appendicular. It's the girdle upon which your arm is attached.